Problem number 31. Based on energy band description, a solid can be classified as insulator. The energy gap between the valence band and conduction band is, obviously, for the insulator, the energy band must be greater than 6 electron volt. Okay, so because insulator is having large energy gap. Okay, so it should be greater than 6 electron volts. So option B is the correct. 32. Problem number 32. The energy gap between the valence band and the conduction band for material is 6 electron volt. The material is obviously, as we discussed, minimum requirement for energy gap for the insulator must be higher, and that is if we'll consider 6 electron volt as a diamond. So the energy gap for the diamond is 6 electron volt. So option A is the correct option for this. Okay. Question number 33. Band gap of silicon. Okay. Energy band gap of silicon, of germanium and carbon. The correct order of the band gap. So if you will see, the band gap of the silicon is 1.1 electron volt. Okay. For silicon, it is 1.1 electron volt. For germanium, band gap is, I think, 0.7 electron volt. So energy gap of silicon must be greater than, it is greater than energy gap of germanium. Similarly, the energy gap of carbon is also greater than germanium. Okay, energy gap of the carbon is also greater than germanium. So option B would be the correct option for this. Let's see question number 34. A p-type semiconductor can be obtained by adding. Option is given: arsenic to pure silicon, aluminum to pure silicon, antimony to pure germanium, phosphorus to pure germanium. Basically, p-type, we have to, for p-type, to obtain the p-type semiconductor, it must be doped with the, or we can add trivalent substrate. Trivalent substrate. Okay, so let's see which one is the trivalent. Arsenic, aluminum, antimony, and phosphorus. So aluminum is the trivalent, which we can add to form a p-type semiconductor. Okay, now see the question number 35. And PN junction diode not connected to any circuit. In PN junction diode not connected to any circuit. What exactly it's mean? It's mean the potential is the same everywhere. The p-type side has higher potential than the n-type side. There is an electric field at the junction directed from the n-type side to p-type side. There is an electric field at the junction directed from the p-type side to n. So the PN junction, if we are not biasing a PN junction, we are not connecting it to any circuit. Obviously, if we are not connecting to the electric circuit, the diode will, this is the P, this is the P and N. Okay, here we will get negative, here we will get positive, here we will get the electron, here we'll get the holes, electrons, holes. What is happening if you're not connecting? If we are not connecting, obviously due to this diffusion or this combination at a junction, what happens? Electric field generated because it's try to make electron hole pair because the positive want to move toward the negative side and negative want to move toward the positive side. Electron want to move toward the p-type and holes want to move towards the N type, and due to this, electric field generated at the junction. Okay, and mostly the electric field moves from N type to P side, N side to P side. This would be the, because positive to negative, because this is a positive one, because at a junction this side is the hole and this side is the negative due to diffusion. Okay, so normally electric field flows through positive to negative. If you'll see at the junction, this is the positive and this is the negative, so this would be the direction of the electric field. Okay, so N type to P type. There is an electric field at junction directed from the N type N side to P side. So C would be the correct option for this. Let's see problem number 36. The contribution of the total current following flowing through a semiconductor due to electron and holes are 3 by 4 and 1 by 4. Okay, respectively. If drift velocities of electrons is 5 by 2 times that the holes, the temperature, then the ratio of concentration of electrons and holes are. We have to calculate the ratio of the concentration. Okay, what is the ratio of the concentration? Just see, you are having the formula, the problem number 36. We are having formula current density. Okay, J is equal to N Q and V. Okay, now number of electrons, number of charge and VV. Okay, so Q is will be the same in both of the cases, because charge of electron and charge of proton. So if we see J for the electrons, we can write J is equal to NEQ V E. Okay, and what about the, so we can say that energy density of electron. Now energy density of holes, energy density of holes, that is also equal to N P Q V P. Okay, as we know, we have to find the ratio of concentration of electrons and holes. So let's take the ratio of concentration of electrons and holes. Just take J N by J, so J E by J H. Okay, current density of electrons by current density of the holes. So now if you see Q and Q will get cancelled, so we will get N E by N P V E by B P. Now see the data. What we have to calculate? Ne by Np. Okay, ratio of concentration. So if we will see Ne by Np is equal to, what can we write? You can put the value, na? Ne by Np is equal to Je by, if we'll do the cross multiplication, so what we will get? So Ne by Np is equal to Je Bp divided by Je H V E. Now we can put the value Ne by Np is equal to J is given. What is J? 3 by 4. This is the J is 3 by 4 and JH is 1 by 4. So we can write here 3 by 4 divided by 1 by 4. And the Vp, the drift velocity of electron is 5 by 2 times that of holes. Okay, if it is 1, then this V is 5 by 2 times of X. Suppose so we can write 1 divided by 5 by 2, or if we will solve this, we will get this 4 and this 4 will get cancelled. This 2 will goes up. 3 into 2 is the 6 by 5. So the ratio is 6 is to 5. I think option A is the correct option for this solution. Let's see question number 37. Okay. Now in 37, when the voltage drop across the PN junction diode is increased from 0.65 volt to 0.75 volt, the change in the diode current is 5 milliampere. So dynamic resistance of the diode is, obviously, what is the formula? So dynamic resistance. So we can write here question number 37. So 37 dynamic resistance. So RD, or we can write RD if we are taking, is del V divided by del I. Okay, del V is nothing but the 0.65 volt to 0.70 volt. So can we do calculate del V from here? 0.7 minus 0.65 volt divided by current is 5 milliampere. So 5 milliampere means 5 into 10 to the power minus 3. 5 into 10 to the power minus 3. If we will solve this, we will get 0.5 divided by 5 into 10 to the power minus 3. So by solving this, we are getting 10 ohm. 10 ohm. So option C is the correct for this. 10 ohm. Option C is the correct option for this. Okay. Question number 38. The gallium arsenide with a band gap is 1.5 electron volt as an LED can emit. Okay. So once we will find the wavelength, we can find the range of the electromagnetic wave given here. So lambda is equal to, we are knowing the formula, lambda is equal to Hc by E. Is you are having H is 6.6 into 10 to the power minus 34. We must take care of the unit, into for C 3 into 10 to the power minus 8. No, sorry, plus 8. Okay, 3 into 10 to the power plus 8. This is the speed of light. Okay, value of H is given and value speed of light you got. So now you have to convert electron volt is 1.5 electron volt into joule, because this unit of the Planck constant you have taken here is in joule. By solving this, we will get 8.26 into 10 to the power minus 6. 8.26 into 10 to the power minus 7. Okay, and that is almost equivalent to 8250 angstrom. Okay, so this wavelength, this is the range 8250 angstrom. This is the length for the ultraviolet ray. Okay, this is the way, this is the range of the ultraviolet ray. So B option is correct option. Okay, so